The accumulation pattern is a problem-solving pattern that we're going to use across many kinds of problems. It's not a new Python type, syntax, or concept, but an approach that we use when we need to do something that combines information from all of the items in a sequence. The accumulation pattern is easy enough to write out in steps. First, we initialize an accumulator variable, then we iterate through all of the items in the sequence, and for every item, we update our accumulator variable, and in the end, our accumulator variable has our result. But for every kind of problem that we're going to solve using the accumulation pattern, we need to adapt its steps for that problem. So let's apply this to the problem of finding the sum of a list of numbers. Suppose that this is our list of numbers, and we could do this just by saying sum equals the first item plus the second item plus the third item plus the fourth item, but I'm going to write this in a slightly different but effectively the same way. I'm going to start off sum as 0, and then I'm going to reassign sum to its previous value, in this case 0, plus the first item. Then I'll reassign it to its previous value, in this case the first item, plus the second item. Then I'm going to reassign it to the first plus the second plus the third item. Then I'm going to reassign it to the first plus the second plus the third plus the fourth item. Of course, this is overly verbose and would only handle lists of size 4, so it's better to do this using a for loop. And now we have a more general solution to our problem, which works with lists of any size. So what we do is we initialize sum to be 0, and then for every item in our list of numbers, then we reassign sum to be its previous value plus that number. And this solution actually follows the accumulation pattern. Our accumulator variable here is sum, and we initialize it to 0. Then we loop over all of the items in our sequence, which is numbers, and we update our accumulator variable by reassigning sum to include that item. And by the time this loop is done, then sum has the correct value, which is the sum of all of the items in numbers. When thinking through how to apply the accumulation pattern to a problem, we need to first figure out what kind of result we want. Specifically, what Python type do we want our result to be? So if we're taking the sum of a list of floats, then our result should be a float. If we're taking the longest word in a sentence, then our result should be a string. Then we think through what should the result be if the sequence is empty. If we're taking the product of a list of numbers, then the value should probably be 1, so I would probably start out my accumulator variable as 1. If we're taking the sum of a list of numbers, then I think that an empty sum should be 0, so I would start out my accumulator variable as 0. Then it's good to think of a good name, which should be short but descriptive, and then we have to think of how should we update our accumulator variable with every new item. So let's do another example. Suppose that our goal is to count the number of O's in a word. This is the code to do that. So here I'm setting word to be onomatopoeia as an example, and I have an accumulator variable OCount, which I start out as 0. Then I loop over every character in my word. I'm going to use the iteration variable C, and if that character is an O, then I update my accumulator variable by adding 1 to it to say OCount equals OCount plus 1, and by the time that this loop is done running, then OCount has the correct value, which is the number of O's in the word, and so we can print that out to the user. So let's walk through this example mechanically to see how it works. So first, word is set to onomatopoeia, and we set OCount to be 0. And the first time we run this, C is going to be the first character, or it's going to be this O. When we run it, this if statement is going to be true, so we increment OCount and change it from 0 to 1. For the N, we don't update OCount. When we run into another O, then this if is going to hit, and OCount gets its previous value plus 1 again. And then M, A, T, when we run into another O, this if runs again. We increment OCount to 3. P, another O, so from 3 to 4. E, I, A. And by the time this for loop is done running, We have the correct value for O count, and we can say there are 4 O's in onomatopoeia. So the accumulation pattern is a pattern that we'll reuse across many kinds of problems in this course when we need to combine information from a sequence in some way.